Thank you. In this lesson, we are going to learn about standard hydrogen electrode. If you look at your 4B table and you will go to the value 0, 0, and you can see a reaction 2H plus 2 electron gives H2, which is the equation for the hydrogen electrode. The hydrogen electrode has got ions H plus. That means it can be any acid. You know, acid is a substance that gives hydrogen ion when dissolved in water. So according to Arrhenius theory, so it must be an acid with a concentration of 1 mole per decimeter cube. And you put a platinum electrode because gases do not conduct electricity. So what is going to happen is you are going to pump in the hydrogen gas on the platinum electrode, and the gas molecules are going to be absorbed on the surface of the platinum electrode, and they are going to act as a substance. Hydrogen gas is going to react from the surface of the platinum. The reason why they use platinum is an inert electrode and it do not react, but it is a metal which can conduct electricity. That is why they are using that, because hydrogen cannot conduct electricity. Your platinum is used there. What is the purpose of this hydrogen electrode? To find the electrode potential. To find the electrode potential of unknown metals. Potential of unknown half cells. Potential of unknown metal. In that half cell you have got an unknown metal. We don't know what is that metal, and you want to find out what is the electrode potential for that. Or for example, you have got chromium and you want to know what is the electrode potential of chromium. So to find the electrode potential, what is electrode potential? These are the values that are given on the right hand side. It shows the difference between the electrode potential of this one metal and hydrogen. Okay, so it is the difference between the electrode potential of this metal and also the hydrogen. So here you must follow the standard conditions. Temperature must be 25 and pressure must be the 101,3 and the concentration must be 1 mole per decimeter cube. Suppose I want to find out what value should I write for zinc. All these values are calculated by doing this similar experiment. Someone wants to find out what is the electrode potential of zinc. What do? You take the zinc and make a galvanic cell with hydrogen electrode. You will get a reading on the galvanic cell. That reading tells you that electrode potential of this, because what is the electrode potential for hydrogen half cell? For hydrogen half cell, the value is 0, 0. We have to find the difference between this and this. This is 0. So whatever value that you get in the voltmeter reading is nothing but the value for zinc. Okay, but if you connect zinc and hydrogen according to this table, zinc is above hydrogen. Zinc is above hydrogen. So what will the electron do? Electron will go from zinc to hydrogen. The one on the top on the right is a strong reducing agent. The one at the bottom on the left is a strong oxidizing agent. So the electron goes from the one element on the top right to the one at the bottom all the time in galvanic cells. So the electrons will go from zinc to hydrogen. Suppose if you connect copper to this, so how do you write cell notation for this? Your anode here is zinc. So we draw the salt bridge, zinc, zinc 2 plus, zinc is your solid, zinc 2 plus is your ions that are present. Then what is going to happen? You take the zinc equation and you swap it and write. Then you come to the hydrogen. What is going to be the hydrogen? What are you seeing here? H plus, aqueous. Then what do you have? Hydrogen gas. Then what are you going to write? Platinum. So you have to put one more line to show it is platinum. So instead of zinc, if you are using copper, so what is going to happen? What change will happen? If you are finding the electrode potential of copper in copper sulfate, I am just changing only these two. And now the electron no longer go from copper to hydrogen. Instead it will go from hydrogen to copper. Look at your table. In your table, hydrogen is above copper. So what happens? Hydrogen is no longer a cathode now. Hydrogen becomes anode. So when you write the cell notation for this, you are going to have hydrogen on the left. So platinum, let's start with the hydrogen equation. H2 is first because we swap the equation. H plus, we don't have to write 2 here, double line. Then you are going to write copper 2 plus aqueous. Whenever ions comes, write aqueous. Then copper, yeah, this is how we write the cell notation for that. So always remember, in galvanic cell, electrons move from the element on the top right to the element on the bottom left. Then the reaction becomes spontaneous and your EMF is positive. Thank you.